Okay, so the next thing that we have here is basically question number 6, which is without using the Pythagorean theorem, show that the points these points are the vertices of a right angled triangle. Okay, so you want to show that these points 4, 4, 3, 5, and -1, -1, these are the vertices. So that these points are the vertices of a right angled triangle. Angled triangle. Okay, so to show that these points are the vertices of a right angled triangle, what you can do is that you can find first of all, you need to know where they are on the xy plane, and that way your job is going to be much easier. So for example, 3, 5 would be 1, 2, 3, 4, and 5. And so that would be, for example, 3, 5. 4, 4 would be this point over here. 4, 4 would be this point over here, and -1, -1 would be this point over here. -1, -1. And so if you join these points together, you will get something that is supposed to be a right angled triangle. And you can imagine that, for example, this is the right angle, and so on and so forth. So you want to show that without using the Pythagorean theorem. So if you want to do it without the Pythagorean theorem, what you can do is, of course, using the Pythagorean theorem, you would find this distance, and you would find this and this distance. And then if I call this, for example, this point A, for example, this point B, and this point C, you could say that, for example, AC squared is equal to, for example, AB squared plus BC squared. And then that way you could, using the distance formula and the Pythagorean theorem, you could show that this is a right triangle. Otherwise, I don't really know how to do this without the Pythagorean theorem. So let's see. Okay, so if you can show that basically these two lines are perpendicular, which we can do, that's one part of this story. And then also, let me see how they have solved this problem. What they have done is that of a non-vertical line passing through the point 6. Slope of AB is equal to -1. It's observed that M1, so this shows that the line segments are perpendicular to each other. The given triangle is right angled, that's the point. Okay, so I don't really remember right now what is exactly the criterion to, or what are the exact criteria for a geometric figure to be actually a triangle. But the way that they have solved this problem over here, they've shown that basically that this line over here is perpendicular to this line, and then well, you can imagine that when you could basically connect these 2 points together, and that becomes, of course, a triangle. Just and that would be basically using logic pretty loosely. But on the other hand, I don't really know how to show, or what are the exact criteria for example, for a polygon to be a triangle. But well, that's a good way I mean, I would say that's a valid way to show that, for example, this is a triangle. Because if you have, for example, this line segment and this line segment, and if you can show that basically this line segment is perpendicular to this line segment, then of course any point on this line segment you can pick, and you can pick any point on this line segment, and then if you connect them together, you will get that would be a right angle triangle. So using this logic, which is, well, not really, there is nothing really wrong with it. Using this logic, you can calculate the slope of this line AB, which is basically the slope of basically AB. You can imagine that you have these 2 points, -1, -1, and you have 4, 4, and you have 4, 4, and so you can, the formula for this, as you know, is equal to m is equal to y2 minus y1 over x2 minus x1. So you can take, for example, this one as x1 y1, take this one as x2 y2, for example, and then this would be, for example, you could write this as, for example, y2 minus y1 is 4 plus 1, and this would be again 4 plus 1, and so that would be equal to basically 5 over 5, which is equal to 1. So the slope of this line is 1. Now, the slope of this line BC, you can imagine that you have these points over here, 3, 5, and you have 4, 4. And so if you put that in this formula, you will get 4 minus 5 over 4 minus 3, and that is equal to basically 4 minus 4 is -1, and 4 minus 3 is equal to 1, so that's equal to -1. Now, we said that basically if two lines are perpendicular if m1 m2 is equal to -1, basically assuming that m1 and m2 are the slopes of the two lines respectively. So we already said that, and of course basically you can say that two lines are perpendicular if m1 m2 is equal to -1, and you can also say that the converse of this is also true, meaning that you can say that if m1 m2 is equal to -1, then you can say that then the two lines are perpendicular. Then the two lines are perpendicular. So I'm going to use this theorem, or whatever you want to call it. I'm going to use this theorem over here. So then basically you can see that the slope of AB, I call it, for example, M1, and the slope of BC, I'm going to call it M2, and M1 times M2 is equal to 1 times negative 1, which is equal to negative 1. Therefore AB is perpendicular to AC. But of course there are a few more things that you need to show to actually prove that this is actually a right angle triangle, meaning that you have to at least show that, for example, the 3 points are not collinear, and so on and so forth. But to just show this very loosely, that basically this is a right angle triangle, we have shown that basically these two lines are perpendicular. That's all that we have done here. Otherwise, this is not a very I mean, the proof is not very right, otherwise. But I mean, what we have done is basically not wrong. You can do that in the case of any two lines, really. Okay, so the next question that we have is that find the slope of the line. You want to find the slope of the line. The slope of the line, which makes an angle of 30 degrees, which makes an angle of 30 degrees with the positive direction of y-axis, with the positive direction of the y-axis, measured anti-clockwise. So you need to be careful about the words that have been used here, because basically in the formula that we had before, while we were basically deriving that formula, we said that basically m, which is equal to tan of theta, and this theta is was some angle which I will talk about shortly, is equal to basically y2 minus y1 over x2 minus x1. We showed that this relationship basically exists between the x coordinate and the y coordinate of any 2 points found on that line, and that is actually equal to tan of theta, and that we called m, or the slope of that line. And what this is basically, if you have some line over, for example, if you have some line like this, and if you have this is the x and y axes, this angle over here, the angle that the line makes with the positive direction of the x axis, measured anti-clockwise, that is called theta. So this angle, the angle that the line makes with the positive direction of the x-axis measured anti-clockwise in this direction, this is anti-clockwise. This is anti-clockwise. Measured anti-clockwise is your theta, meaning that, for example, if you had a line like this, then your theta would be basically this angle over here. Your theta would be this angle over here, and so basically that is basically how we define theta, and then based on that we found this formula for the slope of a line. Now what we have in this question is that we want to find the slope of the line which makes an angle of 30 degrees with the positive direction of the y-axis. The positive direction of the y-axis is basically, this is positive direction of the y-axis. Okay, so I did need to basically go back a little bit, because it seems that I had made a mistake while solving that problem, an arithmetic mistake, and so I had to go back over here and erase a couple of things. These are not relevant anymore. Okay, so now again, the question that we had was basically, you want to find the slope of the line which makes an angle of 30 degrees with the positive direction of the y-axis, meaning that you have a line over here, and suppose that your line is basically, let's suppose that with the positive direction of the y-axis. Okay, so basically I had to do a couple of experiments here to understand. Basically, when you say, for example, with the positive direction of the x-axis, what that means is that, for example, if you have a line over here, the positive direction, where the line basically, where the two lines intersect, this will be the positive direction of the x-axis, and this would be basically the negative direction of the x-axis. Now, by the same logic, when your line is, suppose that your line, for example, somewhere goes through the, of course not like that, but suppose your line goes somehow through the y-axis. So the positive direction of from this point, you can imagine that this is the positive direction of the y-axis, and this is the negative direction of the y-axis. So I can, and the angle is supposed to be measured basically anti-clockwise. So this is clockwise and this direction is anti-clockwise. So that would be basically your angle, which is supposed to be 30 degrees. So I have to make this very, very much smaller, meaning that basically eventually your angle would look like something like this. Eventually your angle would look like something like this, meaning that you would have probably some angle like this, and this would be basically your angle over here, and that would be 30 degrees. So now that's the angle that you have, and this is y-axis and this is the x-axis. Now you want to basically, this angle is 30 degrees, and you want to find the slope of this line. And you know that the slope of, and since I don't have any points on this line, so these y2, y1, x2, x1 is not going to help me at all. So I can just simply get rid of them. I can get rid of these and simply write m is equal to tan of theta. But theta in this formula is the angle that the line makes with the positive direction of the x-axis, basically in a measured in an anti-clockwise direction, meaning that as far as this formula is concerned, your theta is basically this angle. So somehow you need to figure out what this angle is. And in order to do that, what you can do, you can drop a perpendicular probably somewhere. Let's see what happens if I drop a perpendicular somewhere from this line. And since these two lines are parallel, and this is a transversal, then of course this angle is equal to this angle. So this would be a 30-degree angle. And since this is a 30-degree angle, then, and this is a 90-degree angle, this is going to be a 60-degree angle. And so you have now a 60-degree angle over here. That means that, and you know that the sum of these two angles is 180 degrees. That means that 60 degrees plus theta is equal to 180 degrees. So that means that theta is equal to 180 degrees minus 60 degrees, which is equal to 120 degrees. 120 degrees. So 120 degrees is going to give you, and actually I had kind of gotten this answer in the beginning, but I had to go do a lot of thinking. I think I did make a mistake over there. But now you know that your theta is equal to 120 degrees. Now, so basically what that means is that basically if you can find the tan of 120 degrees, then that's equal to the slope of this line. But well, I do not know really the tan of or any trigonometric ratio for that matter of 120 degrees, so you need to calculate it. So you can say that, for example, well, there are a few ways to do this. For example, you can draw a unit circle, and basically, I'm just going to do this once to show you how you can do that, and it's not the best way to do it, but it's possible. So suppose that this is a unit circle that you have, and 120 degrees would be this angle over here. If I suppose that, for example, this is a 30-degree angle. So 90 plus 30 is equal to 120. So this is 120 degrees. So now, for example, tan of 120 degrees is equal to sine of 120 degrees divided by cos of 120 degrees. That you already know. So if I can somehow figure out what sine of 120 degrees is, then and cos of that angle as well, then I can figure out tan of 120 degrees. Now you see that 120 degrees is basically, or let's go for the sine of 120 degrees first, and then we will figure out the rest of the things later as we go along. So sine of 120 degrees is really only this, basically this height over here, this height basically from here all the way up to here. This is basically the sine of 120 degrees. And as you can see, if I in the first quadrant, if I draw a 30-degree angle, a triangle in the first quadrant, something like this, if I extend this thing over here, and if I draw this angle over here, as you can see, this angle over here is, of course, again, this angle over here is again a 30-degree angle. That means that this angle over here is a 60-degree angle. And you can see that the sine of this 60-degree angle, is exactly equal to the sine of this 120-degree angle. And of course, you will see the same thing in the formulas of trigonometry. That is a little bit more straightforward, but if you happen to forget them, you can always take a look at the unit circle. So you see that the sine of 60 degree is exactly the same as the sine of 120 degrees. So sine of 120 degree, I can write it as sine of 60 degrees. And I already know what the sine of 60 degrees is. That's equal to basically square root of 3 by 2. Square root of 3 by 2. That's what I already know. Now the cos of 120 degrees is basically is nothing but basically this distance over here. This distance over here, this is the cos of 120 degrees. So you see that again, it is, if I draw this triangle over here, and then if this is a 30-degree angle, it is going to be equal to, it is exactly equal to this distance over here. It is exactly equal to this distance over here, but the algebraic opposite of that, meaning that this is a negative value, this is a positive value. So I can write cos of 120 degrees is equal to negative cos of 60 degrees. Right? And so cos of 60 degrees is equal to 1 by 2, so that's negative 1 by 2. So I can write this as, so this fraction over here, this ratio over here, I can write it as sine 120, which is square root of 3 by 2, and divided by cos of 120, which is negative 1 by 2, which is equal to, you can cancel these two out and get negative square root of 3. So then basically the slope of this line is equal to negative square root of 3, which is actually the right answer. I did check in the book because I did make a mistake. I had to check. That's one way of finding it, which needs a little bit of logic, and you have to move these triangles around in the unit circle to find that. Another way, which is a little bit better, especially if you are doing, for example, physics, or if you're doing something in mathematics, you can't do this every time. It's better to use some formulas. So what you can do, I think I messed up something over here. So what you can do, okay, I'm sorry, I was playing with my software here, I did mess something up. So what you can do in order to do this using the formulas of trigonometry, and I'm sure you have already read them in, I think in class 10 or class 11, somewhere in trigonometry. So what you can do here is that basically there seems to be two ways to do this. For example, when you have tan of 120 degrees, you can write that as tan of, for example, 90 degrees plus 30 degrees. And then if you could use the formula, for example, tan of alpha plus beta, you know that it's equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. This would, it would be nice if you could use this, but the problem here is that one of your angles is 90 degrees, so, and tan is not, and you know that tan is basically, the tan function is not defined here. Over here, the tan is undefined. So I cannot I cannot write tan of 90 degrees in this formula, so I cannot use it. Alternatively, what I can do is that I can write this as, I can write this tan of basically 120 degrees, I can write it as sine of 120 degrees by cos of 120 degrees. And then we have all of these formulas related to sine of alpha plus beta, sine of alpha minus beta, cos of alpha plus, and so on and so forth, which are basically, you know that sine of alpha plus beta, or some people write them as x plus y, or so on and so forth, doesn't really matter. Sine of alpha plus beta is equal to sine alpha, for example, sine alpha cos beta plus cos alpha sine beta. And of course, you know that Mosquitoes are not very friendly lately. Sine of alpha plus beta is equal to this, and sine of alpha minus beta, you have to choose, you have to change the sign over here, and it's exactly the same formula. And you know that cos of alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. So you have a positive sign here and you have a negative sign here. And if you have a negative sign here, you'll have a positive sign here. So based on these two formulas, you can figure anything out as long as you're willing to basically substitute the values here. And of course, you can always make yourself a list of the very useful and frequently used formulas and keep them as some sort of section in your notes or in your notebook, in your basically trigonometry section, and use them over and over again. I have said this many times. I've never done that actually. So for example, if you want to, based on these formulas, if you want to figure out what sine of 120 degrees is, you can write this as, for example, sine of basically 120 degrees is equal to sine of 90 degrees plus 30 degrees. And then based on this, you can write this as sine 90 degrees cos 30 degrees plus cos 90 degrees sine 30 degrees. And you know that sine 90 degrees is equal to 1. That's equal to 1. This is 1. Cos 30 degrees is equal to square root of 3 by 2. Cos 90 degrees is equal to 0. If this is 0, this whole thing becomes 0. So then basically cos sine of 120 degrees is equal to square root of 3 by 2. And in the same way, you can actually make up some formula for yourself, meaning that you can write sine of basically pi by 2 plus, for example, theta is equal to, for example, here you can see cos of theta. Okay, and then you can use this formula many times as much as you like it. So this is the formula, for example, that we got here. Now, so then based on this, basically sine of 120 degrees is equal to square root of 3 by 2. Should write this more properly. Square root of 3 by 2, and cos of 120 degrees, you can write it as cos of 90 degrees plus 30 degrees, which is equal to basically cos 90 degrees cos 30 degrees minus sine 90 degrees sine 30 degrees. And you know that cos 90 is equal to 0. Cos 90 is equal to 0. So this whole thing becomes 0. And sine 90 is equal to 1. So you have negative sine 30 degrees. Negative sine 30 degrees. Which is equal to negative 1 by 2. Which is equal to negative 1 by 2. And as you can see over here, for example, you can, based on this, you can write, for example, cos of pi by 2 plus theta, for example, is equal to negative sine theta. And then you can use this formula as many times as you want. But in this particular case, cos of 120 degrees is equal to negative 1 by 2. And so now what you can do is that you can write this as, you can write tan of 120 degrees as sine of 120 by cos of 120, which is equal to square root of 3 by 2 over negative 1 by 2. And then you can cancel this out. You can get negative square root of 3, which is exactly what we got over here. So then the slope of this line is negative square root of 3, and as you can see, the slope of the line is actually, it's a negative slope. The line is going downwards, and square root of 3 is approximately 1.7, I suppose, if I'm not wrong. So it's very close to negative 2. Very close to negative 2. So that's basically how you solve this problem. You need to be careful with definitions and everything, and otherwise there is no reason why you should make a mistake like I did. So that is that. Then we have question number 8. I have a couple more questions here. These are good questions. We will do them one by one and get through this chapter. Okay, so the next question that we have is find the value of x for which the points are collinear. So you want, basically you have 3 points over here, x comma negative 1, another point is 2 comma 1, another point is 2 comma 1, and another point is 4 comma 5. 4 comma 5. And you want to find the value of this x such that basically these 3 points are collinear. So basically, if 3 points are supposed to be collinear, what that means is that basically we suppose that, and basically it's a little bit messy, the logic that you use in order to talk about this, but it still works. Suppose that you have 2 lines over here. Suppose that you have these 2 lines over here in the xy plane. So this is the y-axis and this is the x-axis. So I have these 2 lines over here, and suppose that the 2 lines are parallel. The 2 lines are parallel. If the 2 lines are parallel, now suppose that, for example, there are a bunch of points on this line. For example, A, there is this point over here, B, and there is this point over here, C. And of course, A, B, and C are not collinear. But basically we said that the 2 lines are basically have the same slopes. They are parallel lines. Now if I somehow make some arrangements so that the 2 lines remain basically parallel and share one common point over here, let's say that, for example, this C comes over here, and then all of a sudden you have these 2 lines exactly on top of one another, and so you have basically the line. You can imagine that, for example, it's now 2 lines basically on top of one another, for example, AC and BC. You have this line, for example, BC, and you have this line, for example, AC, and they are parallel. These 2 lines are parallel, and they share at least one common point, which is, for example, in this case, C, for example, something like that. So then in that case, then of course the 3 points or any other point that you pick on this line is going to be collinear. Meaning that if I want to show that these points over here, A, B, and C are collinear, if I find the slope of AC, and if I find the slope of BC, and if the slopes, if I set them equal to one another and equate them, then that if the slope of those two lines, the slope of line BC and if the slope of line AC are basically the same, that means that they are collinear. Okay, so now what I'm going to do is that for example over here, based on this well, you could say messy logic, I really couldn't find a better way to explain this thing, but it works. I mean, the logic, there is nothing wrong with it. It's a little bit messy nonetheless. So now if I find, let's suppose that, for example, if I call this point A, for example, B and C, and then what I can do is that I can find the slope of AB, the slope of the line AB, which is the same thing as basically the slope of a line. How you can find it, you already know that. Basically the slope, which we called M, is equal to y2 minus y1 over x2 minus x1. So for example, I can write 1 minus negative 1 over 2 minus x, which is the same thing as 1 plus 1 over 2 minus x, which is equal to 2 over 2 minus x. This is a slope of the line AB. Now let's find the slope of the line BC2. Slope of the line BC as well. And that is equal to basically 5, for example, 5 minus 1 over 4 minus 2, which is equal to 4 over 2, which is equal to 2. 4 over 2, which is equal to 2. So now, if I want to find this x such that the 3 points are collinear, then of course these two slopes have to be the same, based on what we said. So then you can write 2 over 2 minus x is equal to 2. That means that 2 is equal to 4, or let me write another step here, meaning that basically 2 is equal to 2 times 2 minus x. 2 is equal to 4 minus 2x. Negative 2x is equal to 2 minus 4. 2 minus 4, negative 2x is equal to negative 2. X is equal to 1. So that's the value of your x here. Now if x is equal to 1, you can of course verify this as well. So 1, 2, 3, 4 and 1, 2, 3, 4 and 5. That would be 1 point over here, 4, 5. 2, 1 would be this point over here, 2, 1. And then you have 1 point over here, which is 1, negative 1, which is this point over here, 1, negative 1. If x is equal to 1, this becomes 1, negative 1. And as you can see, more or less, these points are, of course, collinear. So that's basically the whole story here. So very interesting logic that they have used in order to talk about this. And in the beginning, I didn't like the way that it had been basically explained, but well, there is nothing wrong with that, and it works really. So now question number 9 is, without using distance formula, show that these points are the vertices of a parallelogram. Okay, the vertices of a parallelogram. So you have these points, negative 2, negative 1. You have 4, 0. You have 4, 0. You have 3, 3. And you have negative 3, 2. Negative 3, 2. And you want to show the points are the vertices of a parallelogram. So first, what we need to do, we need to be clear about what a parallelogram is. So basically, if you have a parallelogram, is very simply this quadrilateral in which these two sides are parallel and these two sides are also parallel. So this side is parallel to this side is parallel to this side. This this condition is enough for a quadrilateral to be a parallelogram. And then of course, if that's the case, then of course you know that this angle is going to be equal to this angle is going to be equal to this angle, this side is going to be equal to this side in length, this side is going to be equal to this side in length, and of course you know that these two angles are going to be supplementary 180 degrees. These two angles are going to be supplementary. These two angles are going to be supplementary. These two angles, any two adjacent angles are going to be supplementary. It's an interesting geometric shape. But the whole thing, that doesn't really matter. The only thing that matters is that this side is parallel to this side and this side is parallel to this side, and then based on that you can conclude that this is a parallelogram. That's the definition. So what we need to do is that let's first try to draw this. So you have 1, negative 2, negative 1, that's 1 point, negative 2, negative 1. Then you have 4, 0, 1, 2, 3, 4, 0. Then you have 3, 3, 1, 2, and 3, 3, 3, and then you have negative 3, 2, which is this point over here. Negative 3, 2. And if I put these points together, it's supposed to be a parallelogram. So now if I call these points, for example, A, B, C, and D, but before I carry on with my solution, I would like to take a look at the solution, the actual solution, see what that is, because I don't want to unnecessarily talk too much. Okay. And for both pairs of opposite sides of quadrilaterals are parallel, hence ABCD is a parallelogram. Okay, that's exactly what I said, so the solution is actually right. So now let me take a few minutes rest. I'll be back to, we will have to basically find the slope of this side and the slope of this side and show that the slopes are the same, and do the same thing for these two sides, and then based on that we can conclude that this is a parallelogram. That's what we need to do. Okay, so basically now let's see, for example, what is the slope of AB. So the slope of AB, for example, the slope of AB is equal to basically it's basically y2 minus y1 over x2 minus x1. That's basically the slope of a line. That's called basically m. So AB, for example, 3. You can write 3 minus 2, 3 minus 2, 3 minus negative 3, and that's equal to basically 1 over 1 over 6. Slope of basically DC, slope of DC is equal to 0 minus negative 1, 0 minus negative 1, 4 minus negative 2, which is equal to positive 1 over basically 4 plus 2 is equal to 6. So that means that the slope of AB is equal to the slope of DC. The slope of AB is equal to the slope of DC. Next, we have two other sides, AD and BC. So the slope of AD is equal to basically 2 minus negative 1, 2 minus negative 1, negative 3 minus negative 2. Negative 3 minus negative 2. That's equal to 2 plus 1 and negative 3 plus 2, which is equal to 3 over negative 1, which is equal to negative 3. Now the slope of BC is equal to 3 minus 0, for example. 3 minus 0 over 3 minus 4. 3 minus 4, which is equal to 3 over negative 1, which is equal to negative 3. So then you can say that the slope of AD is equal to the slope of BC. And so what that means is that basically AB is parallel to DC, and AD is parallel to BC. AD is parallel to BC. That means that this quadrilateral has two pairs of opposite parallel sides. I have two pairs of parallel opposite sides, which means that ABCD is a parallelogram. So that's basically question number 9. Now question number 10 is find the angle between the x-axis and the line joining the points and the line joining these 2 points. So you want to find the angle between the x-axis. Find the angle between the x-axis and the line joining the points 3, negative 1 and 4, negative 2 and 4, negative 2. So let's suppose that you want, actually I think you want to find actually the slope of this line, because that's the angle between the x-axis, if that's the positive direction of the x-axis, and the line joining these points. So it's actually a line having these 2 points on it. So that's going to be the slope of this line, meaning that, for example, 3, negative 1 would be a point over here. 3, negative would be a point over here, and 4, negative 2 would be some point over here. 4, negative 2 would be some point over here. Actually, I shouldn't keep making mistakes. So the point that the line is going to be something like this, and you want to, if by this what is meant is the positive direction of the x-axis, of course the angle is going to be this, which is actually the inclination of this line. This is technically called, this angle is technically called the inclination of, for example, of line L, and then tan of this angle is called the slope of the line L. So what you need to do is that basically we said that m, which is equal to tan of theta, is equal to y2 minus y1 over x2 minus x1. So using this part over here, you can figure out what your theta is. Meaning that you can write tan of theta is equal to basically the y2 minus y1, so that's -2 minus -1, -2 minus -1, and 4 minus 3 here, which is equal to -2 plus 1 over 4 minus 3, which is equal to -1 over 1, which is equal to -1, Now you need to know what sort of angle will have a tangent of -1. It's definitely going to be in the it's definitely going to be in the you see over here, if you take a look at the tan function over here in the first quadrant, your tan is positive. Over here tan is negative, and over here again tan is basically, cos is negative and sine is negative, so again tan becomes positive. Tan is positive. And over here your cos is positive, your sine is negative, so then your tan is negative. So since we are working with angles between 0 and 180 degrees, that means that your angle is, you have tan of theta is equal to -1. That means your angle is basically in the second quadrant. Now the way that you can find it is basically the way that you can find it, well, let's say that I've never actually solved this kind of problem before. Of course, there is the possibility that you basically put together a table, but other than that, you see, it has to be an angle. It has to be an angle for which the sine and the cos are equal, right? Because the ratio is 1. So when you say that, for example, tan of theta is equal to 1, that means that then this is equal to sine theta by cos theta. So what that means is that for this particular angle, whatever that angle is, sine theta is equal to cos theta. And if these two are equal, when you form a ratio of these two, you're going to get a 1. And the only angle that there is for which basically the sine and the cos are equal is 45 degrees. When theta is equal to 45 degrees, then sine of theta is equal to basically square root of 2 by 2, and the cos of theta is equal to square root of 2 by 2. And so tan of theta is going to be equal to basically square root of 2 by 2 divided by square root of 2 by 2, which is equal to 1. Now this happens, so you have this angle over here, 45 degrees, for which tan of 45 degrees is equal to 1. Now this happens in the first quadrant. In the second quadrant, what you need to do is just simply go to the second quadrant and pick an angle where you get the same sine and cos values, but basically the same absolute values for sine and cos, meaning that if I pick this angle over here, of course if I had drawn this a little bit better, you can see that basically the sine of these two angles are the same, and the cos of this angle is basically this distance over here, and the cos of this angle is this distance over here, which are, well, more or less, if I draw this circle to scale, these two would be the same distances, and these are the same distances. So that means that this angle over here is also 45 degrees. So now that means that this angle is basically 180 minus 45. 180 minus 45, which is the same thing as 135 degrees. 135 degrees. That means that it's 1, 2, and 3 times, which is basically 3 times 45 degrees. 45 times 3 is equal to 3 times 5 is equal to 15, 1, and 12, 13, 135 degrees. And of course you can call this angle, you know that this angle is the same thing as pi by 4. So this is 1 pi by 4, 2 pi by 4, 3 pi by 4 as well. You can call it 3 pi by 4 in radian measure as well. So you can say that your angle is either 3 pi by 4 or 135 degrees, which is equal to 135 degrees. Now, as you can see here, the sine of 3 pi by 4 is basically the same amount or the same quantity, which is square root of 2 by 2. The cos of 3 pi by 4 is negative cos of pi by 4. So the sine of 3 pi by 4 is equal to the sine of pi by 4, which is equal to square root of 2 by 2. Now the cos of 3 pi by 4 is equal to negative cos of pi by 4, which is equal to negative square root of 2 by 2. Now that means that tan of 3 pi by 4 is actually sine of 3 pi by 4 divided by cos of 3 pi by 4, which is square root of 2 by 2, negative square root of 2 by 2, which is equal to negative 1. And that's exactly what we were looking for over here. So that means that your angle is theta is equal to 3 pi by 4. If, of course, assuming that we are looking for thetas only between 0 and 180, otherwise you would get innumerably many solutions over here, meaning that you would get, for example, you would get 3 pi by 4 plus 2 pi plus 3 pi plus 4 pi and so on and so forth, meaning that theta would be equal to, I don't remember what I was actually solving here. Between the x-axis and the line joining. Anyway, it doesn't matter, but as far as the solutions are concerned here, you could say that when tan of theta is equal to -1, you could say that this is called, I suppose, the principal solution, but the general solution would be basically 3 pi by 4 plus or minus n pi or something like that, because you would get the same tan value over here, and again another pi, and then again another pi, and so on and so forth in both directions. So I suppose, I'm not really sure about this, but as far as I can remember, it's 3 pi by 4 plus or minus n pi. This would be the general solution. Not important here really, but so now what we were looking for, so now the angle between the x-axis and the line joining these points is going to be exactly 3 pi by 4, as you can see over here as well, between the x-axis and the line joining the points, and the line joining these points. Well, and there is something interesting that you can see here as well, that basically, for example, we say that, so you see this line exactly corresponds to 3 pi by 4 as far as the slope is concerned. And for example, over here, you know that for example, if this is 1, 1, and if this line goes through these 2 points, this is y is equal to x, this line, and you know that the slope of this line is of course equal to 1, and of course this the slope of this line is 1, which is of course the same thing as tan of pi by 4. Tan of pi by 4 is equal to 1, which is, well, the definition of a slope of a line. So so this angle that you can see over here is actually the angle that you have over here. This is pi by 4. So this is something again interesting that you can see in these lines. Okay, so the angle basically over here is 3 pi by 4. Over here is 3 pi by 4. Then question number 10, or 135 degrees, or 135 degrees. Okay, so I'm going to end this video here. In the next video we will talk about question number 11, 12, 13 and 14. 11, 12, 13 and 14. So I'll see you in the next video. Thank you.